Just a moment. Okay. So here basically we were talking about what is the sector of the circle, what is the segment of the circle, how to find the area of the sector, how to find the arc length also. Let me show you. So length of the arc, if we have to find, suppose we are having a circle, and if you are just supposed to, like, if you will find completely, okay, the complete arcs, okay, this arc length, if you will find, that's called perimeter, or we call it circumference of the circle, right? One complete revolution means circumference, and the formula for circumference of the circle is 2 pi r, right?
Yes, ma'am.
Okay, however, if you have to find a specific arc's length, suppose you don't have to find the complete, okay, the length of this complete arc. You just want to find this much. What is the length of this arc? So again, you can use the same formula. This 2 pi r you can use over here. And yeah, just like the area of the sector, the formula for length of arc, it's theta. Okay, what is the angle which is getting created at the center? Okay, this arc is making what angle? Arc. Okay, creating angle at the center means both the end point we will join with the center and we will end up getting the angle. So basically we are talking about this particular angle, theta over 360 into 2 pi r. That will give you the length of the arc. Okay. So yes, this is the another formula. Now, area of the sector we have already discussed. Length of arc we have to find by using this formula. Again, this formula came from unitary method only. Okay. Now the next part is how we will find the area of the segment of the circle. The moment I'll be like, let me explain that. Once we'll be done with that, then you will be able to solve the complete exercise by yourself, because here in this exercise nothing is there. Just find the length of, like, arc length. Either they will ask you to find arc length, either they will, or maybe they will ask you to find the area of the sector, or maybe the area of the segment. Yes, different story will be there, but at the end you will be doing the same thing. So how to find the area of the sector, that we will see. Suppose this is a sector of, uh, I'm talking about segment. Okay, sector we have already discussed. Suppose I'm drawing a chord. Okay, this is a chord AB. We understand segment means area bounded by a chord and the arc. Yes or no? Right?
Yes.
And Rayan, you know that, right? Right, Rayan? Do you know what is segment of the circle?
Yes.
Okay, so let me take one example. Just a moment. Suppose we are having, okay, the angle over here, it's given as 60 degree, and the radius of the circle is given as 21 centimeter. And we have to find the area of the segment. Only this much, the shaded portions area you have to find. Okay. For finding the area of the segment of a circle, we have to do what we have to do. First of all, we'll be finding the area of this complete sector. This complete sector's area will be finding. You can clearly see you are having a sector AOB. Okay, this area will be finding. I mean, I'm talking about completely. You will be finding the area by using the formula theta by 360 into pi r square. Okay, which will give you the complete area. From this complete area, you will be subtracting the triangle's area. The triangle which you can see over here, just this one. If you will subtract this triangle's area, I'm talking about this triangle. So from this complete area, the sector's area, if you will subtract the triangle's area, then you will end up getting the segment's area. Yes or no? Making
Yes,
sense?
ma'am.
Okay. So let's see how can we do so. Just we have to use the formula for finding the area of the sector. Okay, but for finding the area of the triangle, we have to take a few extra steps we have to perform, because we don't have enough information over here. So yeah, area of the segment, area of segment is equals to area of sector. You can call it sector AOB or area of sector minus area of the triangle. Okay. Area of the sector, you already know the formula is theta. Theta is 60 degree by 360 into pi r square. Okay. Pi r square. R is 21 into 21. You can let me check here pi value is given or not. Otherwise, we will leave pi as it is. So yeah, we are allowed to take pi as a 22 by 7. So we can take pi as a 22 by 7 over here, and we'll be getting 6 times 36, and pi is a 22 by 7. So 1 by 6 into 22 by 7 into 21 into 21. Yeah, we have to do the simplification over here, but we'll be able to do that. So 11 into 21, you are getting just that. That will be the area of the sector. Okay, now we also have to find the area of the triangle. You are having such a triangle where the angle, okay, angle O is 60 degree. And wait, no? Yeah. Angle O is 60 degree. And you just know side OA, the length of the side OA is 21. The length of the side OB will also be 21, because this is also the radius of the same circle. Radius is given as a 21. So basically you are having a triangle like this. Okay, where you know this is 60 degree, this is 21 centimeter, and this is 21 centimeter, and you don't know anything else. Now you, if you will recall the area of the triangle formula, only two formula you have learned so far. The first formula was 1 by 2 into base into height, and the second formula was by Heron's formula. If all the three sides are known, then we can find the area of the triangle. So here all three sides are not known. Okay, so Heron's formula we cannot use. Now the remaining formula is the older formula, that is 1 by 2 into base into height. Now in isosceles triangle, there is a property that Since here these two sides are equal in length, so the moment you will drop up, okay, you are just trying to drop an altitude over here. You are just dropping an altitude over here, but this altitude will divide this complete triangle into congruent triangle. Okay, this triangle number 1 and triangle number 2, it will be exactly same, ditto same, congruent. Why? You can understand, initially it was isosceles triangle, so here 21, here 21, already you are having, there is a common side in between, already you are having. Okay, just now you have just dropped a 90 degree, a perpendicular you have dropped. Why you are dropping the perpendicular? So that you can find the area. Okay, 1 by 2 into base into height. Okay, this triangle is triangle a oab. So basically we are trying to find the area of the triangle by using the formula 1 by 2 into base is AB, into height we have dropped, okay, from the vertex. So we can call the height is OD. Okay, now do we know OD? No. Do we know AB? No. Can we find it? Yes. Okay, we can find AB. So if we can find AB, why not we are using Heron's formula? Oh yeah, you can use, after finding AB, you can use Heron's formula as well. But after finding AB, you can also use, okay, this formula, the older formula. You are having two choices. You use any formula, area of the triangle will be same. Okay, I'm just going to show you how to find the length AB and how to find the length OD. Okay, let's see. In Heron's formula, so many simplification will be there, because under root SS minus AS minus BS minus C, you can understand. So the moment you will be able to find AB, and finding OD is also really simple. I'll show you. Okay, some application of trigonometry have we done over here? Yeah, we have, right?
Yes, ma'am.
Okay, so that concept only we need to use over here. So actually these two triangle are congruent triangle. Okay, you can check it. So many different, like I think RHS will also help. Okay, yes, RHS will also help, and other criteria will also help. Okay, there are so many ways to prove this two triangle congruent. We don't have to prove that these two are congruent. You just need to know that why we are going to say the moment we are dropping the perpendicular, it is dividing this side. I am going to declare that now AD and BD is same. Okay, we were having a triangle which was isosceles triangle. The moment we have dropped the perpendicular, now these two sides are equal. Okay, this side and this length are equal. Why it is equal? Due to congruency only. Okay, which we don't have to show over here. Directly we will say the length AD and BD is equal. Making sense? Is it making sense? Afreen and Rayan, we will say we AD BD are equal.
Yes, ma'am.
Okay, and we also know that angle O over here, I mean angle O over here, is equals to angle O over there. We will say we know that it is same. Why? You should know from where it is coming. It is coming from congruency CPCT. Making sense?
Yes, ma'am.
Yes, ma'am.
Okay, so we will say angle O is getting same. Okay, angle O over here, angle O over there is same, and ADBD are same. The moment you will say that angle O over there, okay, these two angle O are equal and ADBD are equal, from there you will get one condition. Let me show you. So you are having a triangle. Okay, you are, originally this complete angle was 60 degree. Okay, the moment you are saying these two are equal, now this became 30 and this became 30. Don't go with the figure. Okay, if it doesn't look like so in the figure, don't worry about that, it will be same. Okay, and the length AD and the length BD will be equal. You have dropped a perpendicular. Okay, you have dropped a 90 degree by yourself. Drawing 90 degree, okay, it's completely okay, because we were trying to find the area of the triangle. Okay, 1 by 2 into base into height, so of course we need to draw altitude. We have drawn a perpendicular 90 degree, and due to that, this triangle OBD or maybe OAD, it became right angle triangle. OAD or OBD, it became right angle triangle. Okay, if it became right angle triangle, then you can use trigonometry. Okay, trigonometric ratio to find the length AD. Okay, let's focus on this triangle. It's a right angle triangle. Okay, we have one of the angle, of course, it is 90, and the other one angle O is 30 degree. Okay, apart from that, what we know, yeah, we also know this OA was 21. And your motto is to find AD. Okay, let's find AD at first. AD. Whatever is AD, that is BD. Okay, so the moment we will be able to find AD, we will say BD is also same. Okay, let's try finding AD. So we will say in triangle AOD, we are going to use trigonometric ratio. Okay, 90 over here, 30 degree over here, 21 over here. Okay, ODA. Now the data which we are having in hand is OA and we are trying to find AD. Okay, AD. So think about it with respect to this 30 degree, with reference to this 30 degree, AD is the opposite side and this AO is hypotenuse. So we want to use opposite and hypotenuse. Sine theta can be used. Can I write sine 30 degree is equals to AD by OA? Making sense? Okay, sine 30 value is 1 by 2. AD we want to find. OA we already know. Now from here AD is 21 by 2. It is coming in decimal, completely fine. Okay, that is 10.5. Okay. Now we know AD, BD are equal. So BD, therefore BD will also be 10.5. And from here we are going to get the complete sides length AB. AB is nothing but AD plus BD. That is 10.5 plus 10.5. That is 21 only, right? Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Okay. Now the this side, OD side, this also we have to find. So we will not try taking the Pythagoras theorem and all. Yes, you can do that way also, but better is try using trigonometric ratio in just, okay, after just taking the trigonometric ratio you will end up getting the final answer. So in the same triangle, how do you find the base? Wait. Yes, Inan, what you said, how do you find the base of the triangle?
Ma'am, I sent that message before you explained this.
Okay. So yes, trigonometric ratio will help us finding the, okay, the base. Now we are going to take the same triangle, okay, the same triangle OAD, and we will start thinking from the beginning. Okay, I am taking the same triangle OAD. This is 90, this is 30. Okay, and we will be thinking from the beginning. This time we want to find OD. Okay, OD, and our OA initially it's 21. So we are taking the initial condition and we are trying to find OD. With reference to this 30 degree, with reference to this 30 degree, of course, this 21 centimeter OA is the hypotenuse. Okay, opposite is AD and the adjacent side is OD. This is adjacent side. Okay, so we want to use adjacent side and hypotenuse. Adjacent side and hypotenuse. Cos theta we will use, right?
Yes.
Cos theta is equals to adjacent over hypotenuse. Adjacent we want to find, we don't know. And hypotenuse we know. Cos 30 is root 3 by 2, right? And from here we are getting OD. Okay. The altitude's length we are getting. The altitude's length we are getting as 21 root 3 by 2. Now we have to find the area of the triangle. Okay. The complete triangle OAB. So area of triangle OAB will be 1 by 2 into base. Okay. We were having the triangle like this, OAB, and we have dropped the perpendicular from O. Okay, so 1 by 2 into base is AB and the perpendicular is OD. We know AB, we know OD. See, this is our AB and this is our OD. We will just put the values and we will do the calculation to get the final area. Still, we are not done. We have to do the subtraction. Okay, area of the sector minus area of the triangle. So this is how we will be finding the area. We'll have 1 by 2, okay, into AB is 21 and OD is 21 root 3 by 2. We will be just doing the multiplication, 21 into 21. Okay, 2 into 2 in the denominator will be 4. You are allowed to leave the answer. I think it is 441 root 3 by 4. Okay, centimeter square is the area. This is how we will be finding the area of the triangle every time. Okay, except there are few conditions where we can use, okay, other way. Always you have to find the area of triangle like this only by using the trigonometric ratios and all. Sin theta, cos theta you can use and you can find the area. Okay, but this question which we have done like this, we could have done this question in a easier way as well. Okay, I'll show you what is the other way, but 99% of the time you will be using this formula only. Okay, this approach only will help you finding the area of the triangle. Okay, now still we have to find the area of the segment. Our sector's area was, our sector's area was 11 into 21. Okay, this was the area of the sector. 11 into 21 will be 231. Yeah. Okay, so 231 centimeter square, that was the area of the sector. And just now we have found the area of the triangle. We will just do the subtraction. While doing the subtraction, if, okay, simplification is possible, please do it. Otherwise you are allowed to leave the answer in the subtracted form itself. Okay, so our triangle's area was, let me do the subtraction, 231 minus this one. Okay, I cannot see any. See, you can take the LCM or maybe you can leave your answer as it is, because even after taking the LCM, simplification is not possible. Okay, so if you will take the LCM, you can keep 1 by 4 out and then you can write your answer like this: 4, 3 times 12, 2 carry 1. And if root 3 value is given in the question, that please use root 3 as a this value. Okay, please use it over here for doing the final, okay, for taking out the final answer. Making sense?
Yes, ma'am.
Okay, so this is how we'll be finding the area of the segment. Okay, if you ended up getting confused, again, I'm summarizing the approach. Okay, just a moment. So you were having segment, segment, okay, segment AB. And the angle over here, it's, suppose the angle over here, it's 120 degree. Okay, suppose the angle over here, it's 120 degree. Okay, and the radius is given as a, let's say the radius is given as a 6. Okay, and the angle is 120 and you have to find the area of the segment. This segment's area you have to find, this one. How you will find the area of the segment? So at first you will be finding the area of the sector, the complete sector's area you will be finding, complete area. Okay, completely you will be finding the area, that is theta. Okay, theta by 360 into pi r square, that will give you the area of the complete sector. But actually you don't want to find the area of the sector. Okay, you just want to find this green colored area. Completely you don't want to find the area. So from this sector's area you will subtract the triangle's area, Which triangle? This triangle. Okay, triangle OAB area you have to subtract from the sectors area. Now, how you will find the triangles area? For that, you have to drop a perpendicular over here, 90°, and at that point only you will say, now this became 60, this became 60, due to congruency, which we don't have to show. Okay, and this AD and BD became same due to congruency, okay, which we don't have to show. Okay, now we can take triangle this OAD or maybe OBD, okay, which is a right angle triangle here, 60°, and you can use trigonometric ratio for finding AD and for finding OD. Okay, for finding AD, of course, opposite side you want to find, so sine theta you will be using, sine 60° is equals to AD by OA, that is 6, and from here you will end up getting AD, whatever it is. Okay, you also have to find OD. Okay, now after finding AD, you need to have clarity that whatever is AD, the same length BD must contain. AD and BD are having the same length. So whatever you will be getting AD, you will say BD is also same, and hence the complete side's length AB you will be finding. Because 1 by 2 into base into height, for finding triangle area, 1 by 2 into base into height. Okay, so you don't know base, you don't know height, you are trying to find that. Okay, so base you will be able to find. Now height, OD, again you will be using trigonometric ratio, and this time you have to find the uh wait yeah this time you have to find the adjacent side, so you'll be using cos theta. Cos 60° is equals to OD by hypotenuse, okay, that is 6, and from here you will be able to get the height OD. This OD you will be substituting in the formula, and the AB, okay, which you will find after finding AD, okay, and adding it with BD, you will be getting the complete length AB that you will be using in the formula to get the area of the triangle. Is it making sense to all of you?
Yes,
Yes, ma'am.
ma'am.
Yes, ma'am.
Okay, and then you can do the subtraction to get the area of the segment. So whenever you have to find the area of the sector, it's really simple. Sector area is really simple. Okay, just use the formula. But when you have to find the area of the segment, these many steps you have to do. Okay, and yeah, if you are clear with trigonometric ratio, if you have done some application of trigonometry, then these are okay, not at all difficult. I was telling you the previous question we could have done by another approach, okay, without even using this trigonometric ratio and all. Why? Because I have shown you an approach which will always help you. Okay, this approach which I was just discussing. Okay, that this is how triangle can be taken, and this is how you can use the trigonometric ratio. Since it is isosceles triangle, of course you will be dropping a perpendicular, and it will divide your triangle into congruent triangle. Triangle 1 and triangle 2 will be congruent. This only happens in isosceles triangle and in equilateral triangle. Okay, if you are having a scalene triangle, that means this is 5, this is 6, this is 7, and when you are dropping a altitude over here like this, then this triangle, okay, triangle number 1 and 2 are not congruent. It's not. So it only works in isosceles triangle, and we are okay, we are having the triangle inside a circle. This is becoming the radii, this is becoming the radii. Due to that only we are getting isosceles triangle. Making sense?
Yes, ma'am.
Okay, so this property which we are using, automatically we are telling the complete angle is 120, then this will be 60, this will be 60. Okay, this length will be equal. This will only happen in isosceles triangle or in equilateral triangle. Okay, not in scalene. Now I was telling you the previous question, the question or the example which I have taken to explain you the concept, that this is how you can find the area of the triangle. That question we could have done by another approach. Actually, there we were having a circle, there we were having the triangle like this, and the angle over here was 60°, and it was 21, it was 21. So have you have you noticed that if this is isosceles triangle, of course this angle and this angle will be same, right?
Yes.
Okay, because this two sides are equal. If these two sides are equal, then opposite to this two side angle will be same. Okay, and if already one of the angle is 60, this is x, this is x, so the remaining two angle will also be 60. Yes or no?
Yes, ma'am.
Okay, hence an equilateral triangle. This is nothing but just an equilateral triangle. So without even using this angle, we could have found the area. You can use the direct formula for finding root 3 by 4 side square. That is the direct formula for finding the area of equilateral triangle, or maybe Heron's formula you could have used for finding the area. Clear?
Yes.
Okay. So yes, if you will realize if the angle over here is 60 degree, please don't do the steps which I was showing you. That we will be doing when there is random angle. Okay, we are not able to identify like it's not equilateral. If 60 degree will be there, definitely it is equilateral. If 90 degree will be given over here as an angle, so it is right angle triangle. Okay, it is right angle triangle. Right angle triangle, you can take this as a, like you can take this as a height and this as a base, or maybe okay, this one as a base. I mean, in right angle triangle, do you know in right angle triangle looks like this? Just a moment. Right angle triangle looks like this. Okay, where of course this is the hypotenuse, and you can call this as a height and this as a base. But if I'll turn this figure, okay, just turn this figure, you can also say this one as a height and this one as a base. So in between height and base, you don't have to get confused. Any one can be taken as a height, any other one can be taken as a base. In our case, if we are having a inside a circle, okay, a segments area we are trying to find, and if our angle is 90 degree over here, so you can take any one as a height and other one as a base. Basically, this will be radii, this will be radii. So you have to multiply both of them. Okay, even yes or no?
Yes, ma'am.
Is it making sense to all of you that in right angle triangle, when 90 degree angle is given, please don't go ahead and use all those steps which I was showing you. That is for random angle, any other angle like 120 degree. Okay, or maybe you can say such angle will be given where trigonometric ratio can be used. Otherwise, how you will use trigonometric ratio? Okay, so don't worry, angle will be given in such a manner so that when you will divide this triangle like this, you will be able to use trigonometric ratio. Okay, so yeah, when the I'm just telling you, when the angle is 90 degree, just use 1 by 2 into base into height formula to find the area. Here your base will be 21, height will be 21. Don't do so many steps. Is it making sense to all of you?
Yes.
Okay, and if 60 degree was given, then you have to identify this is equilateral triangle and the area formula is root 3 by 4 side square. Let's do some questions from here and then you will develop more clarity. Just a second. I'm sharing the screen, just a moment. It is chapter 11, right? Right?
Yes, ma'am.
Yes.
Can you see the screen, everyone?
Yes, ma'am.
See, now you can solve the questions from the exercise. I was telling you, you don't have to do the subtraction. You can clearly see this is how you can leave your answer. Okay, and this is completely fine. So yeah, question number one, find the area of the sector of a circle with radius 6 and angle of the sector is 60°. Basically, you are having a circle, you are having the angle which is getting created over here is 60°. Okay, and the radius is given as a 6. Area of the sector, for all these questions, pi can be taken as 22/7. This is how pi value will be given in your exam. Okay, along with the question that you should take pi as a 22/7 or whatever in decimal. Or if nothing is said, then you are allowed to leave pi as it is. Okay, so yeah, find the area of the sector of a circle. Area of the sector formula is theta by 360 into pi r square. Easily you will be able to solve this question. Okay, so number one, done. Can I leave it?
Yes.
Okay, number two, find the area of quadrant of a circle whose circumference is 22. Quadrant of a circle means you are having a circle, okay, and divided in 4 equal part. Okay, the way you used to have first quadrant, second quadrant, third quadrant, fourth quadrant in coordinate geometry, here quadrant of a circle, that means only this area you have to find. Okay, any one of the quadrants area you have to find, all are just equal with each other. So you can, there are two ways to do it. Actually, we are dividing circle in 4 equal part. 4 equal part. So you can say that complete circle's area pi r square divided by 4. Either you do like this, or you should identify quadrant means here will, there will be 90°, here 90°, here 90°, here 90°. That's what happened in coordinate geometry. When we are drawing the quadrant, that means x-axis, y-axis making 90° with each other. Yes or no? Okay, so here our complete circle is getting divided in 4 equal part. That means each angle, okay, angle over here has to be 90°. Then only 90 plus 90 plus 90 plus 90 will make 360°. Making sense?
Yes, ma'am.
Either you solve this question by taking pi r square by 4, because our complete circle getting divided in 4 equal part and we are trying to find the area of each part. Either you do like this, or you use sector formula, that theta, that is 90° by 360 into pi r square. This theta by 360, when you will simplify, 9 4 times 36, so here also you are going to get 1 by 4 only. Both will give you same answer. Clear? Is it clear?
Yes, ma'am.
Yes, Afrin, is it making sense?
Yes, ma'am.
Number 2 also I am leaving. Okay. Number 3, the length of minute hand. We'll be doing this particular question. The length of minute hand of a clock is 14 centimeter. Length of minute hand of a clock is 14 centimeter. Find the area swept by the minute hand in 5 minutes. So minute hand completely. If you will focus on the minute hand, just the minute hand, it will complete one revolution in 60 minutes. Yes or no?
Yes,
Yes.
ma'am.
Okay, so in 60 minutes, it covers 360 degree. In 60 minute hand covers 360 degree. In 1 minute hand will cover 360 by 60. That means 6 degree. Making sense?
Yes.
Okay, and here you have to check what the length of the minute hand is given. Find the area swept by the minute hand in 5 minutes. So we are trying to check in 5 minutes what angle it is covering, what angle it is creating. If it is going from here to here, how much angle it is covering. If the minute hand going in here to here in 5 minutes, what angle it is covering. That's what we are going to check. So in 60 minutes, it is covering 360 degree. In 1 minute, it is covering 6 degree. In 5 minutes, it will cover 6 into 5. That is 30 degree. Yes or no? Now you have to find the area of the sector. This complete sector's area you have to find. In 5 minutes, what angle minute hand is covering? Yes or no? Given that the length of the minute hand is 14 centimeter. Okay, Afrin, you have got the answer as well. So yeah, length of the minute hand is given over here. That we will take as a radius of the circle, 14. And area of the sector formula is theta by 360 into pi r square. R is 14. Pi can be taken as 22 by 7. Is it clear to all of you?
Yes.
Inan, are you getting it?
Yes, ma'am.
So we are done with this one as well. Okay. Number 4, a chord of a circle of a radius 10 centimeters obtain right angle at the center. I was telling you, when there is right angle at the center, and in case you have to find the area of the segment, okay, segment, then just for finding the triangle area, you should do 1 by 2 into base into height. Any one, okay, any of the side you take as a base, other side you take it as a height. Basically, you have to do the multiplication, okay, 1 by 2 into base into height. Okay, so if you will do the multiplication of 2 into 3 or maybe 3 into 2, it's the same thing, right?
Yes.
That's why here, while taking the base and height, you can take any one as a base, any one as a height. Actually, here base and height will be same because it's a circle. Of course, these two are nothing but just the radii of the same circle. So that confusion is also not there. 2 into 3, 3 into 2, that confusion is also not there. Okay, you have to do the multiplication of these two radii only, right?
Yes, ma'am.
Okay, so a chord of a circle of radius 10 centimeters obtained right angle at the center. Chord, here a chord is there, okay, which is making right angle at the center. It is making 90 degree at the center. Radii is given as a 10 centimeter, 10 centimeter. Find the area of the corresponding minor segment. Area of the segment means area of the sector. Sector's area will be theta by 360 into pi r square. R is 10. Okay, and we are trying to find the segment area, so minus this triangle's area, and triangle area 1 by 2 into base is 10 into height is 10, and we are done. Yes, we have to do the simplification, but we are done. Is it clear? Is it clear?
Yes.
No.
Yes, Rayan, is it clear?
Yes, ma'am.
Inan, are you there?
Yes, ma'am.
Is it clear?
Yes, ma'am.
Okay, we also have to find the area of the major sector. So for finding the area of the major sector, okay, I was explaining the first class that there are two ways. Either you take the complete circle area and from there you subtract the minor sector area, or you find the angle. If this much angle is 90 degree, then the remaining angle must be, this complete will be 270, right?
Yes, ma'am.
Okay, so theta by 360 into pi r square. You just put everything in the formula, you will end up getting the area of major sector. Clear? Is it clear to all of you?
Yes, ma'am.
These all the questions quickly I'm explaining. You have to do it. Okay, I was telling you in this complete exercise, in this complete chapter, nothing is there. Just the area of the sector, area of the segment. That's what we have to find. Nothing else. Okay. We are done till number 4. Number 5 says that in a circle of radius 21 centimeter, an arc subtend an angle 60 degree. This is the okay example I ended up taking over there. 60 degree. Okay. And I was telling you when it is 60 degree, you need to identify that this is nothing but an equilateral triangle. Okay, if the angle over here is 60 degree, automatically it will be equilateral triangle, and equilateral triangle area formula, direct formula is there, root 3 by 4a square, which came from Heron's formula itself. So you can use direct formula for finding the area of equilateral triangle. Okay, let me check here. Do we have to find the area of the segment, find the length of the arc, area of the sector, and find the, yeah, you have to find the length of the arc, that is theta by 360 into 2 pi r. This 2 pi r came from the circumference formula only. Okay, area of the sector, easily you will be able to find, and area of the segment. Okay, we were doing it, but we were using longer approach. Please don't use that. That approach we will be using for other triangle. If it is not 60, if it is not 90 degree, then we will use the longer approach, trigonometric ratios and all. Okay, however, this two type of question can be done directly as well. So yeah, you have to do till question number 5. I'll be taking from question number 6 in the next class. Okay,
Yes,
total
ma'am.
15 questions are there. From question number 6 I'll take in the next class. Please finish till number 5. Okay, yes, Inan, Rayan and Afrin, is it okay?
Yes,
Yes.
ma'am.
Okay, then I'm keeping